Okay, so hi everyone. I'm Ohad, and I also an educator, and I'm going to talk now about those topics. So first, we will talk about what is the Stratasys global education and why do we have that. Then I will talk about the Stratasys curriculum that I created. We will talk about the new MakerBot curriculum, about GrabCAD, Workbench, and how we provide it for free for you. The extreme redesign contents that we have right now, and then we will have questions and answers. So this is the Stratasys brand purpose. Now what happened? Okay. And this, can you see my screen?
Yes, yes, we can see your screen, no problem at all.
Okay. Okay, so in Stratasys Education, we actually provide 3D printing solutions. It's not only about the 3D printers, it's about the entire ecosystem that we provide to empower your students and to empower you as an educators. And what we would like you is to take our technology and everyone's 3D printing technology to the cutting edge to transfer the way that we use technology today. And if you will read our curriculum, you will see that we wrote our mission that Stratasys Education is committed to promoting 3D printing in education and bridging the gap between academia and industry. So whatever we do, we actually study from the industry what the industry would like to have or what are the difficulties that the industry has today and try to bring it to you as an educator in order that you will work with your students to know how to mind those gaps. So in Stratasys, we actually have an entire ecosystem. We have machines from MakerBot, from this desktop machines, to a very high-end machine like Fortus and Connex. We have the direct manufacturing. We have the verticals, which is like aerospace, automotive, medical, that each one of them, we work with them and we study what do they need. And they work directly with industry. And we also have Thingiverse and GrabCAD, which is our social network site. So now I'm going to talk about the curriculum. We launched that on December 2014, and we actually had it from before. The entire curriculum, I wrote it, so I'm well aware of what is going on there. And I used it with my students as well. In the curriculum, you are going to have an historical review of what made this revolution and how your students can be part of that. We're going to go about the advantages and disadvantages of 3D printing, explain the current emerging 3D printing applications, but what we actually wanted to do is to do things that you can only do with 3D printing. This is why I called it something that moves something, because only with 3D printing you can interlock parts within parts that you cannot do with any other technologies in an easy way. And what we aim as well is that a business school, a design school, and an engineer school can use the same curriculum. We also understand that you have your own agenda and you have your own courses. So the idea was, how can we do a modular curriculum that can be part of your course, but not to be an independent course if you don't want it. So We actually started the curriculum with the pilot in Tamasp Polytechnic in Singapore and in Wentworth Institute of Technology in Boston. In both, we had a great success. I will talk mostly about Wentworth Institute of Technology. And now we will. Okay. Okay, I will tell me if you can hear. You cannot hear this. Okay, so if you go to our website, you can see this video about Wentworth Institute of Technology, about what they've done, and why we call it something that moves something. But if we go here, we can see that the students is actually going to create things that are moving. And when I visited them, we had lots of talk about, if you see this, about how to do those kind of parts and what do you need to know about the tolerance and about how things move together and how can you have a fully assembled working parts out of your 3D printer. So the entire idea was to have an easy-to-use curriculum that you have in the curriculum. You have a 3D printing curriculum guide. You have step-by-step working into 23 weekly units. So a regular semester is 14 units. We know that, but we did this curriculum for 23 units. So you can decide which unit would you like to do. We actually okay, you have like lab hours and you have lecture hours. We provide you all presentations, and within the presentation you will have a presenter notes. You have sample STL files that you can print with your machine, and we check those files with all of our machines and we know that all of them work. There are differences between the files for PolyJet and the files for FDM. You have the project, students' project suggestions. You have case studies that we made them step by step using designing thinking methodology. You have a final project exam and relevant exam units. This is our learning objective from the curriculum. So if you will go to the site and download it, you can see, you can learn about everything about that. And those are the different units. So if we look here, we have one unit about introduction to, so this is like historical review, an introduction to the course, introduction to 3D printing, what is a mesh, how do you do control print with our software? So you actually have a software guide and a gear system, dynamic surface, and 4D printing and more. The entire idea of the core of the curriculum was how to allow the students to have a career readiness. We see what the industry asks for, and this is what we want them to do. We want them to be ready to work in the industry. We sat with some major companies and we learned what tools do they use. Like Airbus, they use our Fortus machines, but actually they want the people to know more than that. So this is, the curriculum is for that. So if you want to download the curriculum, it's for free. You go to Stratasys website, you click on industries, you choose education, you click on 3D printing course, then it will take you to this side. You can see the units, and if you will click on download the curriculum, you can sign and you will get an accessibility to all presentation and material. You don't need to pay. This is for free because we believe that we should provide those things. So as I told you before, the curriculum is fully flexibility. You can have the entire unit, and you can decide which units would you like to teach. What we actually recommend that the four first units, you will use them as an introduction to this course. What we see in now university worldwide, that in one course they do the introduction, and in other course they do the other units. So it means that in the first semester you do the introduction and they do one assignment, and then in the second semester they use the course for different parts as well. Now we talk about the layout of the course. So we have historical review. You know what? I will go over that. So this is how you get the curriculum. In each unit, you have the learning objective. You have an assessmental questions that you can ask yourself and you can ask your students to know exactly if they understood the unit. The idea was, how do we measure the success was one of the most important parts for us, to really have a working curriculum that you can use in your academia. Within this page, you can see also that we also recommend you about lectures. We provide the lectures, and we also recommend you to work in the lab and to provide the information. And this is the first presentation that we have. So I'm not going to talk about all the slides of the presentation. I'm going to show you only sample slides from a few presentations. But historical review, this is how we start the course. And yes, the course is in Japanese as well, in German, and we have Chinese is going to come, and French. So we actually go from the first beginning of making. But what is important here is to see in the instructor's guideline. We provide you guideline. So what we understood that instead of providing you a book and presentation, we provide you all instructor notes in one presentation that you can go over with your students during class, and it can help you how to teach that as well in class. So we go from the very first beginning to the first industrial revolution, to the second revolution, the mass production, and you can see all information down here, to digital revolution, and then to the third industrial revolution. In between you have more slides, of course. And then to the informational revolution, the personal computer, and from personal computer we go to 3D printing. But after talk about 3D printing, we talk about parametric design and what are the capabilities and options. And then back to the future, which is like taking the historical figures and use 3D printing and 3D scanning to do the same thing. Now, so this is the historical review, but when we go to unit 4 and above, we start to talk about something that moves something. How can you create something that moves something? How do you know the tolerance? How do you know how to work with a machine? How does our material actually work, and how can you take these to use them as advantage? So the very first beginning is gear system. Now the gear system units, I know that the designer schools will say, okay, we're not going to teach this. I'm an architect and I teach this my students. The entire idea of that is like to have different levels. So within the presentation, we have different levels. We have a level for designers or business schools, which is very first level, and we actually show you how can you do the start. But after that, we have more advanced level for engineering school. And actually, the feedback that we heard is like some professors take our presentation now for teaching gear system because they say that we put a good knowledge inside that. So within this unit, we're going to talk about how does this system works, and we are going also to talk about Da Vinci case study. How does Da Vinci use gear system, or creating a ball system, and you have the STLs for each one of them. Each STL we have for PolyJet and for FTM, because there are different tolerance within those technologies, and there is different resolution within those technologies. So, and we have the assignment. One of the assignment is like the Da Vinci machine. So it's find the Da Vinci machine sketch. We provide you 2 sketches. Consider the way in which 3D printing different from the way that they designed it. And this is like a case study that we did with Da Vinci. So first, what is that the Da Vinci sketch? So we talk about the sketch, we provide you the information, and then we designed it. So when you take a sketch of Da Vinci that was designed for wood and metal, and now you print it at once in 3D printing, there are things that you need to consider and things that you need to think while doing so. So this is a great example of talk with your class. Right? When you use different technology, different machines, different materials, there are different things to consider while you design. And this is why we took the design thinking, I'm sorry that it looks like that, the design thinking method, and I developed it to making a process. So you define what you want to do, you made an ideation, prototype, and then in the prototype, you test it. You choose a technology, you do the CAD to CAM, you fabricate it, and everything is going back and forth until you get the final part. And this is actually what we did in Stratasys. So nothing worked at the first print. It was from CAD to CAM. We first designed it. We thought about tolerance. We thought about how can we print these parts. Then if you look at those parts in here, how long does it need to be to allow it to be bent? Because Da Vinci designed it with metal. The behavior was completely different. So now we needed to redesign it and to think how does the spring movement will work. And then you can see a few of our prototypes. So it was not only to think about the prototype itself, but also about the user interface and how can you work with its parts. So you see here we added some places for our fingers, and you have all the information within the presentation. And then you can see that it's work and it moved, and you have those files in the presentation. We actually updated this file, and now I will move my part so it's much more free and it worked great. And what is the most important is about the tolerance, the minimum thickness. Consider where to have support. So most of the people that will design in 3D printing, they will say, okay, I will take up the support and this will work. But you need to think where the support is going to move or how it's going to go out. So all of that we have in the presentation, and what we see now, that students that took this course are now, they took an automotive course after that, and they actually talk about mathematical way of how to move parts within the cards, and they had all these equations that they made a model for that, and they showed that the actually mathematical equation really works. And this was great feedback that we got, that they saw. Now we tried to do it before, but we never thought about that maybe the support material is still stuck inside, and this is why the machine didn't move. And after having your curriculum, we thought about tolerance and how to take material out and how to do those kind of things. So the design thinking process again. Dynamic surface, this is a unique talk of how in one surface, let's call it, one part can move the entire surface. So, and within this dynamic surface, so if you want to have an assembled part, you talk about nesting. How do you put the part in your design, and how do you place it within the machine? So we know that you have Object Studio and Catalyst that will put you the part within the printing bed, but sometimes you want the layering system to work differently. So this unit talk about nesting, which is something that usually you talk when you laser cut or mill, but no one talk about it when you do 3D printing. So nesting is all about how do you lay the things that you do. And from research, we saw that everything started with fashion industry, about the pattern and about how to waste less material. And then you do it with different technologies. But what about 3D printing? So we talk about waste in the way about the movement of parts. And I will go over that fast. So then how do you place it within your tray? So we talk about orientation and how does the layer system works. So this we start to talk about mechanical and about the how does the part works, orientation, spacing within the parts. And I can tell you that Airbus engineers use this presentation now to train their people, because it's really help of how to think about those kinds of parts and things. And the assessments in the curriculum, so we provide you an idea of how to assessment your students, also exam bank for each unit, and we get a great feedback from the students worldwide. So we have many universities that already joined and ran the curriculum. We would like each one of you that if you join and you ran the curriculum to send us a feedback email, to ask questions and send us some images, if you can, of you and your students within the parts or videos of the moving parts. Most of the students' feedback are great. And what we see that it's not only the students now, it's the educators. So in some universities, actually one professor took this course and taught different professors that now implementing those methodological ways within their courses. So we talk about professors that never thought about technologic way that are now using 3D printing in part of that, as part of that. You can see some articles online about the success stories and faculty impressions. So what we know is like one of that is currently working with one of Wentworth is one of their faculties who teaches kinematics, and it's like introducing 3D printing to kinematics, because the dynamic surface unit is all about kinematics. And then when the professor saw those kind of things, he understood that now it will be easier for him to teach kinematics, because students will really understand and will create kinematics within the class. Assessment data. So this is from Wentworth Institute of Technology. You can see they ask their question after a course. Actually, they asked it twice. The second course were even much successful than that, but you can see that most of the grade that they provide were awesome. The last question, like one of the questions were, if this course provides you new information and necessary for design and print objects, and you can see that most of them answer that 10. So I would like all of you to use this curriculum, or maybe go over that. You don't really, if you don't want, you don't need to use it, but go over the units, send us feedback, and also take part of it to your class. Some of that you will say, okay, I'm going to teach it in digital fabrication class in general, and some of that you will say that you are going to teach it in 3D printing courses. What we also do, if you send us some feedback and things, some university will send them material back. So if we like the videos that you send us and things like that. I will also say that we have a package, education pack, that you can ask your reseller, which is include materials and machines in a lower price, which can be easy to use when you do the curriculum. Now, I will talk in short about the MakerBot curriculum, which is kind of nice and short. It's a short book that you can download from their website. And it's provided you different activities for class, which relation to subject that you study within the class. So you need to go to their education website, which is makerbot.com/education, and within that you can take the MakerBot in the classroom paper. So, like, this is one of the things in this curriculum we have step-by-step of how to create it with free softwares, how to design and to use it within classroom. It's mostly for K-12, but I can say that my students use that. I ask them to go over that, review that, and they said that they study lots of new things out of that curriculum as well. We need to remember that when you print with MakerBot, we don't have solvent support material with most of the MakerBot machines, and we have only one extruder. So you need to think about tolerance and how to remove support in a different way. You can see that within the curriculum. Now, I will also talk about another tool that we provide for our education customers. So recently we bought GrabCAD, and GrabCAD has this tool called Workbench. We decided to provide it for free for educators and for students, so you can collaborate with your students. So what is that tool? If you go to GrabCAD website, you can see a video talk about this tool, and you can join as well. The tool is actually to allow you to collaborate while working on one project. It means that if you have a solid or any 3D modeling CAD that you want to collaborate within few people together, like Google Docs, you can do that now with CredCut. It allows you to work together, to share knowledge, to visual things, to write comments and mark places, and all that is on the cloud. So it's kind of a Dropbox that people can write you marks over your CAD files. We have feedback from groups that really work together. So this group are actually created a car together, and we like did all the parts together, like working collaboration, and I will go over. It allows you to forget the words, but to see how parts are made and to take it to the assembled parts. You have a desktop and mobile app. You can watch the model online, so actually it allows you to upload the model. This is the way that you can ask your student to share the files within the class, to review them in class, and also you can give comments to your students on the files, but it's also to allow them to collaborate together and to work on one project all together with all parts. It's not only for 3D printing, it's 3D CAD modeling in general, and you can do sections, compare parts, and all of that together. So what I said before, we try to provide you a stack of solutions, from the CAD solution to the 3D print to the fabrication solution, and also we have our Stratasys direct manufacturing that will provide you discounts for your students. So instead of if you say that you cannot print everything within your lab, you can send your file to the Stratasys direct manufacturing, and then they can fabricate it for you as well. We still know that having the machine within your site, you have a highly advantage of that. But we understand that for one assignment, you don't need a large system, or if your lab is if you have like an assignment that you really need to assign fast and your lab is fully worked, you can use this. Now, we have the Extreme Redesign Contest, which is now running. It's for engineering and for art, for high school and middle schools and post-secondary graduation students. All of them will not have only a winner as a student, we will have a winner as an institute as well. And we are going to provide some, the winners will get, they can see everything, like what is the winning, what would the winner will receive and things like that. And if you want to, you can go to Stratasys website to enroll this. And I'm finishing soon. Hello? Okay, to enroll this, you go to Stratasys website and you go to Industries and Education, and you just write Extreme Redesign, and you can see the challenge and how to enroll it.